efficient and advanced decisions in all fields.
Okay, so any more answers?
Ma'am, data is very necessary for to train the AI models to gather the valuable insights for the business. So from the valuable data only we can achieve the exact output. So the analysis of data, the raw data itself, we can write easily, but the insightful data are necessary for the analysis process. So without data, uh, nothing will work.
Okay. So, like, you can think of the data being generated daily, like from social media, mobile apps, sensors, or even the online transactions. So, basically, the data science helps organize to find the meaning in the chaos. So, it also answers questions like what do the customers want next? Where should we open a new store? And, like, how can we detect the fraud faster? Basically, it provides a pathway to find the needs. So okay, so as you can see that it combines techniques from statistics, computer science, and domain expertise, and basically the main goal is to convert the raw data into meaningful information for decision making. That is there. So what is data? So data can be structured or unstructured, and it also comes in various forms such as text, images, or numbers, and it is the foundation upon which data science builds models and conducts analysis. So basically it is very important to understand the types and the sources of data to conduct data science algorithms. So data science is everywhere. For example, Netflix and Spotify use it for recommendations. Amazon uses it for inventory and customer predictions. Banks use it for fraud detection. Healthcare uses it for diagnosis diseases. And even the sports team use it for performance analytics. And nowadays, even the government is using it for policy making. As you can see that data science importance of data science, so it basically plays a critical role in various industries by enhancing decision making processes through data driven insights, and businesses leverage data science to improve operational efficiency, customer satisfaction, and overall profitability. As you can see that data science consists of many forms. In the diagram you can see that, and as the volume of data continues to grow exponentially, the demand for data science skills is increasing day by day. And as you can think of a gateway to high paying and high impact careers. So now let's talk about the opportunities. Data science is consistently ranked among the top three jobs globally. The roles would be data analyst, data scientist, business intelligence analyst, and machine learning engineer. And as you can see, the data science process first would include the basic understanding, then the modeling. In modeling, feature engineering is there. So basically, feature engineering is to transform, to perform different feature selection is there, image is there. Then we will proceed to model training. That would include to train the model by using various algorithms, assemble parameter tuning, retraining, and model management. Then here comes the model evaluation. So here we'll evaluate the model by doing cross validation, model reporting, and A/B testing. Then comes the deployment. So here basically the scoring, performance, monitoring is done, and then the customer acceptance is there. So basically iterating through these stages allows for continual improvement of the analysis. And as you can see that the data acquisition and understanding is taken from, like, it depends upon the data source, like from where the data has been taken, the pipeline, the environment, wrangling, exploration, and cleaning. So as you know that two types of data are there, one is structured and one is unstructured data. So let's move to machine learning. So what do you think machine learning is?
Ma'am, uh, to make the computer or to make the computer to mm, think like a human, but uh, that is artificial intelligence. For machine learning itself, it's just comes under feeding data. From that data, we need to teach the computer to for recognition like something, not with some like deep learning. Just I think so. It's based upon the supervised learning.
Hello, ma'am.
Yes.
Training models to training AI models based on regression techniques, ma'am.
Okay.
Basically, ma'ams learn from the data and make decisions. It's all about in machine learning.
Ma'am,
Ma'am,
machine learning is the process of inducing human-like intelligence into machines, like training models with already available data sets and deriving some result from them.
ma'am, machines learn itself from without explicitly coding.
Okay.
Ma'am, machine learning is a subset of artificial intelligence that enables systems to learn from data, identify patterns, and make predictions or decisions without being explicitly programmed. So, data-driven pattern recognition and predictions and decision making. And application-based means image recognition, NLP, and recommendation systems.
Okay. So basically, you can imagine teaching a toddler how to recognize a cat. So for that, you don't write rules like it has four legs or has whiskers. You just show them lots of pictures of cats, and over time, they figure it out. That's exactly how we teach computers in machine learning. So we don't program them by step. Instead, we feed them data and they learn from the patterns. And as you know that machine learning is a part of artificial intelligence where the computer learns from examples, not instructions. So you can think of it like this, that traditional programming is rules plus data, and machine learning is data plus output that is equal to rules. So the machine learning learns the rules on its own. So let's play a quick game. Raise your hand like if you have used any of this recently. Netflix, Google Maps, Instagram, Amazon, Google Translate. And you guess what? Like all of them use machine learning. And as you know that Netflix learns what you like to watch and it recommends the same genre movies. It learns the pattern of the movies you have watched recently. And the Google Maps predicts traffic, and also the social media, that would be Instagram, that detects what kind of content you engage with. if you see a certain type of content once, then for a while it keeps on repeatedly getting the same type of, like, basically the genre is repeated, and the model runs and it shows you the. So, like, there are three types of machine learnings. So first is supervised learning. Like, you can think of it like a teacher is guiding a student. You feed the data and the correct answers. Second is unsupervised learning. It includes no labels, nothing, and the machine finds the pattern itself. Third is reinforcement learning. So the machine learns from trial and error, like you can think for an example, like how we learn to ride a bike. So basically, machine learning is a subset of data science focused on algorithm that learns from data. It enables systems to improve their performance on task, and as they gain more experience. This technology is widely used in applications such as recommendation system and image recognition. So as you can see in the diagram, machine learning is a part of AI, that is subset of AI technique which use statistical methods to enable machines to improve with experience. And deep learning is the subset of machine learning which will make the computation of multi-layer neural network feasible. So as you can see, supervised learning. So the model training is done with label data. Unsupervised learning, model training with unlabeled data. Reinforcement learning, model take actions in the environment, then receive state updates and feedbacks. So basically, in reinforcement learning, the machine learns from trial and error, like how we learn to ride a bike. So in supervised learning, the model is trained on a labeled data sets with input output pairs. So what do you understand by labeled data set? Can anybody answer?
Ma'am, it was a well
Reports with
structured data,
their respective outputs.
pre-processed
Like
data, ma'am.
in a class of animal, if we label it which are cats, then it is called label data.
Okay. Some more answers?
Ma'am, it was a well structured pre-processed data.
Ma'am, it's classified.
Okay, that's correct. So basically, supervised learning is when the machine learns from labeled data, meaning that each input comes with the correct output. So the goal is to learn a mapping from input to output so it can predict results on new data. So you give the machine both the question and answer during training. The machine learns patterns in the data and tries to generalize to unseen inputs. So some real time examples would be fraud detection. So basically, in this, they are fed past transactions labeled as fraud or not fraud, so the model can learn to flag the future frauds. Email, the second example would be email filter. So in this, the system is trained with emails labeled as spam or not spam to filter new messages. So third example is disease diagnosis. So it uses patient data and past diagnosis to predict diseases. Stock price prediction. In this, the input is the past stock trends and output is the future prices. Image recognition is like it feeds labeled images of cats, dogs to classify new images correctly. So the common algorithms in this are linear regression, logistic regression, decision trees, support vector machines, neural networks. So as you can see in the supervised learning, the label data is fed for model training. Then during the prediction, test data is there. Then hence the data, sorry, the output is given. So in this, we feed both input and output to the model. So now here comes the unsupervised learning. So basically unsupervised learning deals with unlabeled data. So the system tries to find patterns, groups or structures in the data without knowing the correct answer. So it is often used for clustering and association tasks such as customer segmentation. And the main goal in unsupervised learning is to discover hidden structures or relationships in data. And the like how it works is that the machine explores the data and learn patterns like clusters, association without being told what to look for. So some real-time examples would be customer segmentations. For this, as you can like you must have used customer like Amazon and Flipkart, etc. So basically e-commerce companies group customer by buying behavior to send targeted ads. For music recommendations, the top prime example would be that Spotify clusters listeners based on a listening pattern to suggest similar songs. Third example would be website behavior analysis. So basically, it analyzes user click paths on a website to optimize user experiences. And fourth would be market basket analysis. That would be that find associations like people who buy bread also buy butter. One last example for this would be DNA pattern discovery. That would be find genes patterns from raw genetic data. So for this, common algorithms used are k-means clustering, hierarchical clustering, PCA, that is principal component analysis, and association rule mining. As you can see in the diagram, first the input raw data is fed, then the algorithm is run, and then the output is. So third one is reinforcement learning. So basically, reinforcement learning is a goal-oriented learning method where an agent learns by interacting with an environment, getting rewards or penalties based on its actions. So the goal is here to learn the best strategy policy to maximize long-term rewards. So how it works? So in this, the agent takes an actions, it and then it receives a feedback that would be reward or punishment. Then it again adjusts the strategy. So over time, it learns which actions leads to the best cumulative award. So reinforcement learning is inspired by behavior psychology and involves agents making decisions to maximize rewards, and it is commonly used in gaming, robotics, and autonomous systems. And the learning process is trial and error based, focused on long term rewards rather than immediate results. So, some real time examples for this would be game playing AI. So, AI plays games like chess or Go, learning strategies through trial and error. Second example would be self driving cars. So, the car learns to navigate by rewarded for staying in the lanes or avoiding crashes and obeying the rules. Third example is robotics. So, a robot learns how to walk or pick up objects or navigate through obstacles. Fourth example would be stock trading bots. The bot learns trading strategies to maximize profits through repeated simulations. Fourth would be smart assistants. Voice assistants learn how to respond better based on user interactions and corrections. So, the core concepts for this are the agent. Agent is something that learns the learner or the decision maker. Environment is where the agent operates. An action is what the agent does. Reward is feedback signal. Policy is strategy to choose actions. And in this Q learning, deep Q networks and policy gradient methods are used. So, like the comparison between three learnings. So, I have a quick questions. Which of them, like which of these three learnings uses labels?
Supervised learning.
Supervised learning.
Supervised learning.
Supervised.
Okay, and what about the reinforcement learning?
Trial and error based method.
Reward system.
It is
Rewards
a
are
trial and
penalty.
error based learning.
Reward system is in use.
Okay, so the goal for supervised learning is
It learn.
It learn from the data and make the correct data.
Selection of
into
algorithm.
It predicts
It's
from the
a
raw data.
structured learning.
okay, and the goal for unsupervised learning is
It is an unstructured learning, and it learns itself by the shape of the shape or color, like
By finding the similarities
Ma'am,
between different
similarities.
objects.
it will
To
please
discover hidden
answer one
patterns.
by one. Please do not answer in group. One by one, calmly answer.
So it is the unsupervised learning will be useful to discover hidden patterns in data.
Okay. And what is the goal for reinforcement?
To maximize the rewards.
Okay. Some other answers?
Ma'am, maybe the selection of algorithm.
Okay. Some other answers?
I'm focusing on long-term rewards rather than immediate results.
So for this maximize reward is the goal. Okay. And like output for supervised learning is
The labels which we are using.
okay. So basically the classification, right? Some other answers?
Predicted from the inputs.
Yes, that's correct. And the output for unsupervised learning is
ma'am, the data is classified into like they don't have the labels like this is that, this is that, this is that, but they are just being classified.
So basically, it uses clusters and
Clustering.
patterns. Yes, that is correct. And for reinforcement, what is the output?
Based optimized strategy.
That
Okay, some other answers?
it learns a strategy that maximize the total reward.
Okay.
Trying to find inherent patterns, but there is no predefined goals.
Okay. So no other answers?
A sequence of actions that maximize cumulative reward over time, ma'am.
Okay, so basically for this is that optimal policy. So can you guys give me an example for supervised learning?
Okay. Ma'am, basically
Email
classification.
Real-time example I'm asking.
Weather prediction system.
Classification for breast cancer classification and regression for
Okay. Some more answers?
Real estate price prediction.
A movie recommendation system.
Email detection.
Spam filtering.
Email spam
Spam
detection.
filtering in email.
Okay. Yes, those are correct. So example for unsupervised learning would be?
House price prediction.
Customer segmentation.
Yes, that's correct. An
Market
example.
basket analysis.
Yes, that is also correct.
Customer segmentation.
Yes.
Anomaly detection.
Okay. Yes, that's correct.
Medical priority, high priority, medium priority, low
Yes,
priority.
that's correct. And for reinforcement learning, what would be the real-time example?
Robotics.
Gaming.
Gaming.
Okay. Gaming AI. Okay.
Manufacturing automation.
Gaming AI.
Okay. Yes. Yes. And self-driving cars.
Autonomous
would be also-
vehicles.
Autonomous vehicles.
Yes, that's correct.
Traffic lights.
Yes. Okay, so now we will proceed to the like data science life cycle. So basically, we need to understand the problem you are solving from a business or domain perspective. So like we need to ask what is the goal and what value are we trying to deliver. So for example, if you work for a bank and the goal is to reduce bank loan defaults, so like how can we improve it? Like we can improve it by improving customer retention. That would be a clear problem statement that guides the rest of the process. So basically, it is very important to understand the problem you are solving from a business or a domain perspective. Then only you can solve the problem ahead. The second is data acquisition. So in this data source is also there, and the pipeline, like sources would be databases, APIs, cloud storage, IoT sensors, logs, Excel sheets, etc. So basically, it sets up the pipeline to automate the data flow if needed. So in this, at first the data is collected. So effective data collection is the next step after problem identification in the data science process, and it involves gathering relevant data from various sources. So the sources could be anything, from wherever you want to take data. and the quality and quantity of data collected significantly impact the performance of machine learning models. So after this, data pre-processing and cleaning is there. So data pre-processing is crucial for cleaning and preparing the data for analysis and modeling. So basically, this stage often involves handling missing values, removing duplicates, and transforming data into suitable formats. So proper pre-processing ensures the data is accurate and ready for analysis, leading to better model performance, that is better model efficiency. So in this process, wrangling is something that is fixing data format issues. Example, converting text to date. Explorations would be like looking at distributions, patterns, correlations. Cleaning is removing duplicates and handling missing values and fixing outliers. And for visualizations, we use charts to make sense of data and spot trends. That would be Matplotlib, Seaborn, Power BI. And it helps generate insights and communicate with non-technical stakeholders. So, what is EDA? Exploratory data analysis is the process of analyzing data sets to summarize their main characteristics, often using visualization. So, it helps the data scientist to understand the data structure, pattern, and anomalies. So, through EDA, insights can be clean and inform the choice of modeling techniques. So EDA is the first step in analyzing data. It helps to understand the data, find patterns, identify outliers before moving on to complex analysis. So, and it also aids. Just wait a second. Sorry for the interruption. Yes. So it aids in choosing the right methods for further analysis by providing insights to the data structure. And it also, like, fourth step is it helps in detecting anomalies or errors easily, ensuring the quality of data before modeling. And why do you think it is important? Why do you think it is important?
To easily understand the patterns in the data.
To get the characteristics of the data.
Ma'am, we can get the clear information of the data using that. That like, if we don't know this machine learning and all, then you can also use this ED.
Okay. Some more answers?
Errors can be identified in early stages.
Okay, yes. So basically, it is important, like before you model your data, you must understand it, right? So it ensures data quality and it also guides for feature engineering and it helps choose to write algorithms and it also prevents us from concluding wrong conclusions or biased results. So, what is feature engineering? So, basically, feature engineering involves selecting and transforming variables to improve model performance. It involves selecting modifying or creating new features to improve the model performance. So it is basically a creative process that can significantly enhance the predictive power of machine learning models, and it is basically transforming raw data into features that better represent the model. And good feature engineering requires domain knowledge and understanding of the data. First, the raw data is collected, then, as you know, data pre-processing is done, and in data pre-processing there are three steps, that is wrangling, exploration, and cleaning and visualization is done. And post that, the features are there, and then that is given for modeling, and then the insights are given. So basically you can think of an example like extracting day of the week from a date, or creating a customer tenure feature like encoding category variables, that is male is equal to 0 or female is equal to 1. So feature selection and scaling can also happen over here. So model selection. So model selection is the process of choosing the most suitable machine learning algorithm for a specific problem. So as you already know that different algorithms have different strengths and weaknesses based on the nature of data and expected outcome. So common algorithms are linear regression, decision trees, support vector machines, and neural networks. Logistic regression is also there. So basically it means to choose the right algorithms, and training the model on a label data, that is done in supervised, or letting it discover patterns that would be unsupervised. And parameters are also tuned, that is hyperparameter tuning for best results. So model training is a process of teaching a machine learning algorithm to make predictions based on data. So this involves feeding the model a training data sets and adjusting its parameters. The quality of training data directly affects the performance of the model. So as you can see that the data is collected from the warehouse, then the data preparation is done, and then it is fed it for model training or tuning. Then the trained model makes the predictions on new data. And as you see, the parameters are tuned hyper parameter tuning for best results. Now here comes the model evaluation. So model evaluations basically assess the performance of a trained machine learning model using metrics such as accuracy, precision, and recall, and F1 score. And some would be rock oak curve, RMC, that is root mean score squared error, etc. So it helps us determine how well the model generalizes to unseen data. And techniques like cross validation can be employed to ensure the robustness of the evaluation. So we are check how the model performs using metrics like classifications, that would be accuracy, precision, recall, and regressions would include RMSC, that is root mean squared error. And cross validation techniques would be test train split or confusion matrix, etc. And if the performance is very poor, you might go back to the feature engineering or modeling to enhance it. So what is overfitting and underfitting? So overfitting occurs when a model learns the training data too well and fails to generalize. And underfitting happens when a model is too simple to capture the underlying patterns in the data. So balancing complexity is crucial for building robust machine learning models. So as you can think that overfitting happens when your model learns the learning data too well, including its noise and errors, and fails to generalize the unseen data. So you can think of it like a student memorizing answers for the test, and they will score high if the questions are repeated, but failed if asked something slightly different. So as you can see in the graph, the training error, that is blue, becomes very low because the model is too good on training data, and test error increases after a certain point, showing it performs poorly on new data. So for this, the symptoms is that high accuracy on training data and low accuracy on testing real world data. For this, a real time example would be a spam detection model that memorizes every past spam mails but fails to catch new ones. So for underfitting, it happens when your model is too simple to capture the underlying patterns in the data. So it does not learn enough. So you basically can think of it like a student who barely studies and guesses all the answers. Neither past or new questions make sense to them. So as you can see in the graph, both training and test error are high, and model is too basic or wrong for the problem. So for this, the symptoms are poor accuracy on both training and testing data, fails to learn meaningful relationship, and one real-time example for this would be using a straight line, that is linear regression, to model a curvy relationship like sales over time. So as you can see, the best fit, that is middle zone. So this is the sweet spot where the model is neither too simple or not too complex. So training and test are both reasonably low. So this the model generalizes well, performs well on both unknown and unseen data. So why is it important? So balancing underfitting and overfitting is the core of model tuning in machine learning. So achieve a robust model, you need to choose the right algorithm, tune parameters, that is hyperparameter tuning, use cross validation, apply regularization, that is like L1 L2, and gather quality and diverse data. So now we will proceed to the hyperparameter tuning. So basically, hyperparameter tuning involves the optimizing the parameters that govern the learning process of machine learning algorithm. Techniques such as grid search, random search can be used to find the best combination of parameters. So the proper tuning can significantly enhance the model performance and accuracy. So hyperparameters are the settings or configuration that you define before a training a model. They are different from a parameter which are learned from the data during training, like weights in linear regression or neural networks. So example of hyperparameters are decision tree, and the hyperparameters for this is max underscore depth, min underscore samples underscore split, and for random forest that would be n underscore estimators, max underscore features, and for k nearest neighbors would be n underscore neighbors, and for svm would be kernel type, c, gamma, and for neural networks, it would be learning rate, batch size, number of layers, activation functions. And why do we need to tune them? Because the right combination of hyperparameters can improve model accuracy, reduce overfitting or underfitting, and it also shortens the training time, and it makes your model more robust and generalizable. And the tuning techniques for this is use grid search. So basically we in this we try every possible combination for from a defined set of hyperparameter values. Random search is also used, and that means randomly sample combinations, that is faster and more efficient when you have a large search space. It trades accuracy for speech, it trades accuracy for speed, and Bayesian optimization, genetic algorithms, and AutoML, that is advanced tuning using smart search techniques or automation. So for real-time example would be, suppose you are using random forest for predicting loan defaults. So if n estimators is too low, then the model underfits. And if max underscore depth is too high, then the model overfits. By tuning both using grid search or random search, you find the best performing version of your model. So the aspect of hyperparameter is that process of choosing the best parameters, like hyperparameters for a model. And why do we use it? Because to improve model performance and generalization. And how the techniques are using grid search, random search, Bayesian optimization, or AutoML. And when it is used after the basic EDA, that is exploratory data analysis, feature engineering, and model selection. So the deployment of model, once a model is trained and evaluated, it needs to be deployed in a production environment or for real world use. So it involves integrating the model into an application and system where it can predict, like it can make predictions on new data. And it requires continuous monitoring, and it is very essential to ensure that the model remains effective over time. So the tool technologies available for data science and machine learning, that includes languages like Python, R, and libraries such as Pandas, NumPy, Skitlearn, TensorFlow, that provides powerful functionalities for data analysis and model building. And cloud platforms like AWS, Cloud, Google Cloud, Azure offer scalable solutions for data storage and machine learning deployment. So the real world applications, data science and ML learning have numerous applications across various sectors that would include finance, healthcare, and marketing. So for instances, we predict analytics can, like predictive analytics can forecast customer behavior, while machine learning can assist in diagnosis diseases from medical images. So the versatility of these technologies enables organizations to gain a competitive edge through data driven strategies. So the challenges in data science. So the challenges in data science are the data is available or not, and the quality of data, the integration of data, and the ability to scale data. Security and privacy concerns are there. Model interpretability is there. Quick advancement in technologies is there, and lack of talent also is there. So basically, it is to ensuring ethical use of data and addressing biases in algorithms are critical considerations. And continuous learning and adaptation to evolving data landscapes are necessary for data scientists. So ethical considerations in data include data privacy, bias, and transparency in algorithm decision making. And it is to ensure fairness and accountability in machine learning is paramount. And data scientists must adhere to ethical guidelines to maintain public trust. So future of data science and ML is that the future of data science is very promising, and with advancement in artificial intelligence and big data technologies, so the emerging fields like explainable AI are gaining traction to improve model interpretability, and continuous learning and adaptations are essential for data scientists to stay relevant. So as you can see that there are various career opportunities in data science. That is, first is data analyst, data engineer, machine learning engineer. So each role requires a unique set of skills and expertise in different areas of data science. and continuous education and hands-on experience are vital for advancing in the field. So for learning resources are there, like you can learn from Coursera, edx, Udacity for courses on various topics, and even joining the community can help you enhance. So the conclusion is that data science and machine learning are revolutionizing the way we analyze and interpret data, and staying informed about the new tools and techniques is essential for success in this field, and embracing the challenges and opportunities will drive innovation and growth in data science. Okay, some some of you have raised hands. Okay, so basically the disadvantages of overfitting. Yes, I think somebody have asked about the disadvantage in the overfitting. So basically the model, like what happens is that the model learns the learning data too well. So including the noise and outliers. So what happens that it becomes too complex and memorizes instead of generalizes. Like the model becomes too complex and it memorizes instead of generalizing, and that results in poor prediction as well. So as you can see, for example, a fraud detection model overfits by learning specific fraud cases, but it fails to catch new, so slightly different fraud patterns, which defeats its purpose. And disadvantages of underfitting is that if the model is too simple to capture underlying structure in the data, it does not learn enough from the data. So the issue occurs is that low training accuracy is also there, so it misses patterns and oversimplified assumptions that would like may wrongly assume linearly or independent when it is not true, and no value in deployment. So EDA can be done in two ways in real world, like depending on the team and the project goals. Like first would be using like code also, like that is most common in data science. Tools for this would be Python with pandas, Matplotlib, or Seaborn or R. So it is basically ideal for complex data pre-processing, model building, automations. Example, you can write a code to find null values and plot histograms, calculate correlations. And second way would be using BI tools. That is used for dashboarding or business users, that is Power BI, Tableau, Excel, and it is ideal for visual data exploration, sharing dashboards with stakeholders, and it is easier for non-programmers. So that is there. So, but data scientists use Python, R for deep EDA and modeling. Yes, basically it memorizes. Yes, Satish, that is correct. So basically it memorizes instead of generalizing it. Like because due to the high complexity, it does that. And there is a risk of misleading results as well. You can use AWS because like it is most widely used in industry. Azure can be used for Microsoft ecosystem knowledge, like that would be really beneficial for Power BI, Excel, etc. And GCP would be easiest UIs like for you because that is used by Kaggle Vertex AI, right? So you can use it. You can use like start with Google Colab, then explore AWS or is Azure ML as you want. Okay, then we will conclude today's session as the time is up. Thank you, everyone.
Thank you, ma'am.
Thank you, ma'am.
Thank you very much, ma'am.
Thank you. Thank you.
Okay.
Thank you. Thank you, ma'am.
Thank you, ma'am.
Okay.
Thank you, ma'am. Thank you, ma'am.